What's up everyone, and thank you for choosing to learn with LAM. Today we're going to be talking about percent composition. Now, before we can really go into percent composition, we need to talk about mass percent first. So let's start there. Whenever you're dealing with a percentage, the truth is that you're looking at a partial over a total times 100%. Just think about it. If I ask you how you did on a test, so your test percentage, you'd take the number of questions you got right and divide it by the number of questions total, then multiply it by 100%. If you're a basketball fan, maybe you're interested in a player's free throw percentage. To calculate that, you'd take the number of free throws they hit and divide it by the number of free throws attempted in total, and again, multiply by 100%. The questions that you got right, the number of free throws that were hit, these are both partial values in comparison to the total number, and mass percent is no different. So if I'm calculating mass percent, I want to find the mass of a part of a compound and divide it by the mass of the entire compound, so the total. There's actually another way to do this also, because sometimes we're not given the masses we need. It's possible to calculate mass percent using a partial molar mass and the total molar mass. Some examples will probably help with the understanding. If I have 5 grams of sodium chloride in a solution that has a total mass of 25 grams, and I want to know the mass percent of sodium chloride in the solution, then I'm going to divide the partial mass, so just sodium chloride's 5 grams, by the total mass of the solution, which includes the sodium chloride, which is 25 grams. I'm going to multiply that by 100%, and that gives me 20%, meaning that sodium chloride takes up 20% of the entire solution's mass. Like I said earlier, I can still calculate mass percent without mass by using molar mass. For example, if I want to calculate the mass percent of hydrogen in water, I need the molar mass of hydrogen, which is 1.01 grams per mole. But remember that there are 2 atoms of hydrogen in water, so I'll multiply it by 2, and that gives me 2.02 grams per mole. The molar mass of water is 18.02 grams per mole, and that's including the hydrogens, of course. So then the mass percent of hydrogen in water would be 2.02 grams per mole, divided by 18.02 grams per mole, times 100%, which gives us 11.21%. All right, now we're ready for percent composition. Percent composition really just means finding the mass percent of each individual element in a compound. So let's take a look at sucrose, which is C12H22O11. In this case, the percent composition is just the mass percent of carbon, the mass percent of hydrogen, and the mass percent of oxygen in sucrose. The mass percent of carbon is 12.01 grams per mole times 12, because there are 12 carbons in sucrose, divided by 342.34 grams per mole, which is the total molar mass of sucrose, all times 100%. For hydrogen, the equation is 1.01 grams per mole times 22, divided by 342.34 grams per mole, again, all times 100%. And for oxygen, the equation is 16.00 grams per mole times 11, divided by 342.34 grams per mole, all times 100%. Now that you see how each mass percent is set up, it's just a matter of solving each equation. I would definitely encourage you to put these numbers in your calculator yourself so you can really see where all the numbers are coming from. For carbon, we now have 144.12 grams per mole divided by the total times 100%. So the mass percent of carbon in sucrose is 42.10%. For hydrogen, we have 22.22 grams per mole divided by the total times 100%, which gives us the mass percent of hydrogen in sucrose as 6.49%. And lastly, oxygen is 176.00 grams per mole divided by the total times 100%, meaning the mass percent of oxygen in sucrose is 51.41%. Notice that all the mass percents add up to 100%, which makes sense because all of these parts make up the whole. And that's how you do percent composition. As always, if you have any questions, please leave them in the comments below. Good job, everyone. If you find that you need a little extra help, please feel free to check out my other videos for tips and tricks on how to succeed in school. And as always, thanks for learning with LAM.